8.5, the volume of a cone, and it's more of the same. We just have a different formula to use. At the very top of your page there, you have space to write the formula for the volume of a cone, and it is 1/3 times pi times r squared times height. And just to pick apart the pieces of this a little bit, so we've got, we're talking about the area of the face of the cone. That's right here, right? Pi r squared is the area of a circle. Then we're going to multiply it by its height, just like we would in a cylinder, except that the cone that has the same face and the same height in comparison to its corresponding cylinder, the cone is only 1/3 the volume, okay? So if we think about that just for a second, here is a cylinder, and the area of this face is pi r squared. And then to get the volume, we would multiply by its height. Now, a cone with the exact same height and the exact same circular base, so the cone that fits inside that cylinder from top to bottom is going to have 1/3 the volume of the cylinder. And you can think about that because from the top down, so this is the side view, if we could see kind of through the cylinder and the cone. If this was the top of the cylinder, all you would see is the point of the cone, okay? So all of this around, down to the bottom, all this 360 degrees is empty space if this cone is sitting inside the cylinder. 2/3 of the space inside the cylinder would be empty, okay? Another way to say that is if you took that cone and you filled it with sand and then you poured that sand into the cylinder, it would come up to about here. It would take up 1/3 of the volume of the cylinder. Okay, so here's our formula. There's a general understanding of how it works, and let's dig into our examples. And of course, we're going to leave our formula at the top of every homework page that we do. We're going to write it over and over and over again in an effort to remember it and use it more quickly. Example 1. Tracy makes her own frozen yogurt treats in cone-shaped paper cups. Determine the volume of the frozen yogurt treat shown to the nearest cubic centimeter. All right. The volume of a cone is 1/3 the volume of the cylinder that has the same height and base. We already know that. We have already derived our formula. We're just going to use it, plugging in the information that we need. So here we go. Volume equals 1/3 pi r squared h. And there's multiplication in between each of these variables, okay? Well, 1/3 is not a variable and pi is not a variable. They're just known values. They're numbers. But r is a variable and h is a variable. So here we're going to sub in r and h based on the picture that we see. 1/3 times pi. R is radius, which is 4 centimeters. So we're going to put 4 in there and make sure it's still squared. And we're going to multiply by h, which is 12. And now it doesn't really matter what you multiply by what first here. As long as we do our exponent first, the rest of it can just go in our calculator as a string of multiples. Okay, so we've got 4 squared is 16. 16 times 12 is 192. And then you can divide by 3 and multiply by pi. So if you do this very carefully in your calculator, you'll end up with approximately 201 cubic centimeters. Make sure you don't forget the units. So if the lengths of radius and height are measured in centimeters, then we're working in centimeters, and because it's volume, it's cubic, okay? And what does that really mean? That means if you had a little box that had side lengths of 1 centimeter, 1 centimeter, and 1 centimeter, this would be 1 cubic centimeter, okay? If you filled that with water and poured it into the cone, you'd have to do that 201 times in order to fill the cone. in order to fill this popsicle cone, okay? Okay, in example 2, we're still asked kind of the same thing. We're going to get the volume of the cone, but we take a look at our picture and the dimensions that we're given, and we notice, are we given r? No, we're given the diameter. So one step we're going to have to do before we can even apply our formula is to determine the radius. Okay, that one's pretty easy. But let's take another look. Are we given the height of the cone? No, we're not. We're given the slant length. Okay, now what do you see? Boom, boom. We've created a right angle triangle in which we know the hypotenuse, and I have a feeling that we know the base as well, one of the legs of the right angle triangle, because that's going to be the same value as the radius, which we'll find out first, okay? So step 1, since the diameter is 10 meters, comma, we know the radius is 5 meters. So r equals 5. Well, now let's use that information to determine the height of the cone. We have the hypotenuse and we have the base, or one of the legs, which is the same as r, which is 5. Now, what tool do we have in our toolbox that allows us to find the lengths, relate the lengths of a right angled triangle? We are going to apply the Pythagorean theorem. Because really all we did is create a right angle triangle inside our cone. So what do we know? Well, we know it's a squared plus b squared equals c squared, where c is the hypotenuse. So let's plug in what we know. A or b doesn't matter. 5 is one of the legs. So let's just say we have a squared plus 5 squared equals 8 squared. Okay? Let's simplify. We've got 5 squared is 25 equals 8 squared, which is 64. Let me briefly interrupt myself in order to point out a very common mistake. A very common mistake would be to go from this step here and write this. Well, I just have to subtract 5 squared from each side. So 8 squared minus 5 squared, that's 3 squared. Wrong. Okay, 8 squared, take away 5 squared, is not 3 squared. You'll be able to see that in the next step. We're going to subtract 25 from 64. We're not going to end up with 9. It's going to be a much larger number. Why is that? It's because you did not use BEDMAS. If you're making this mistake, you did not use BEDMAS. Okay? What you did is you subtracted the base of the power before actually multiplying out the exponent. 5 times 5, 8 times 8. Okay? Do not do this. This is wrong. All right? Exponent first, then addition and subtraction. Let's carry on. From here, I'm going to find out the height here. A squared, A in this example is the height. I could have used the letters H and R. Okay? Could have done that, but I didn't need to. So this guy is labeled A for me. Could be H. Doesn't matter. I'm going to subtract 25 from both sides. A squared equals 39. And now to find out the value of A, I have to square root both sides. Well, A squared, if I take the square root of that, I'm left with just A itself. And here, because 39 is not a square number, I want to leave it as precise as possible, and I'm just going to get square root of 39, and then because I'm just going to round to the nearest decimal or so, I'm going to get A equals the square root of 39 in my calculator, 6.2. Now, if I want to be real helpful to myself, I can rewrite that as H equals 6.2 meters. Now I'm ready to carry on and apply my formula for the volume of a cone. All right. So now we're going to apply formula. Here we go. We've got volume of a cone equals 1/3 times pi times r squared times h. 1/3 times pi, r is 5, square it, h is 6.2. Okay, I need to square my 5 first, that's 25. Then I'm going to multiply by 6.2, all right? And then I'm going to multiply by pi, and then I'm going to divide by 3. And when I put all that in my calculator step by step, I get 162. What is the units? Meters cubed, cubic meters. What does that mean? That means if you had a box that had a height of 1 meter, a width of 1 meter, and a depth of 1 meter, you would have to fill that box 162 times, pour it into the sand pile, and then you would get the volume of the sand pile that we have. All right, so this one was, again, a couple of steps more difficult. We were given the diameter, not the radius, but that's easy. Radius is just take the diameter, divide by 2. And then we had a right angle triangle formed, okay? And we used Pythagorean Theorem, remembering that the hypotenuse is always by itself on the other side, and the square of the two legs gets added and is equal to the hypotenuse. Algebra gives us our height of 6.2, and then we can apply our formula for the volume of a cone. Example 3, find the height of the container. So this time we are going to be given the volume, we're going to be given the radius, and we're going to have to use the same formula to find the height. Okay, there's 2 ways to do this always. You can either rearrange the formula first with its variables there, so that h is by itself, and then you plug in all the stuff you know on the right, or you can just plug in what you know and use basic algebra to strip away the information to get h by itself. We're going to use that strategy here. Let's see what we know. A fountain firework is packaged in a conical container. Okay, fireworks. The volume, so we know the volume of this container is 210 cubic centimeters. We know its diameter is 8 centimeters. What is the height of the fountain firework to the nearest 1/10 of a centimeter? All right, well, using our formula, we see right away we're given diameter, so we want to make sure we know that radius is 1/2 times the diameter, which is 1/2 times 8, which is 4. So we've got a radius of 4 centimeters. Notice how we can do a string of statements, but if we're using equal signs, we need to make sure that everything is actually true. So radius is 1/2 diameter. In this case, d is 8, so this one's also true. And 1/2 of 8 is 4. So 1/2 of the diameter is also 4, and radius is also 4. If I can't say that this is equal to that, then I can't use equal signs in between, okay? Make sure that we're using true statements in math. Here we go. Substitute the known information into our volume formula. I'm going to rewrite the volume formula. Maybe I'll come over here. We've got volume equals 1/3 times pi times r squared times h. Plugging in our known information, we know the volume is 210. 1/3 times pi. Don't ever think that pi is some unknown. Pi is not a variable, okay? Pi is a known number. It's 3.14, yada, 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 okay? It is just a number. Plug in r, which is 4 squared, and the height We do not know. So we're going to leave h there. Now you notice, yeah, I have the volume and I'm only missing one variable, it's h. So I should be able to do this just fine and dandy. Now, to isolate h, I can do it two different ways. I can do it piece by piece, divide this side by 16, then divide by pi, then multiply by 3. Or I could, if I'm good with my calculator and I'm good with my brackets, I know how to do this properly, I could actually group this whole piece and divide both sides by that whole piece. I'm not going to do that. I'm going to go step by step. I'm going to first divide both sides by 16, but I'm just going to write it out so that you can kind of pay attention to how to rearrange an equation. So I'm going to erase this for a sec. Go back to 1/3 pi 4 squared h. All right. So to divide by 16, I've got now 210 divided by 16. On this side, I still have 1/3 pi h. All right. So dividing by 4 squared has been taken care of. I divided this side by 4 squared. I divided this side by 4 squared. And this is what I'm left with. Okay. Next step, I'm going to divide both sides by pi. Okay. So this side, if I divide it by pi, I'm just left with, I'll leave a little bit of space, 1/3 times h. And on this side, dividing by pi just puts pi in the denominator here. So I've got 210 over 16 pi. And now you can see how what I said earlier makes sense. I could have just ended up dividing by, this piece right here is 16 pi. So why don't I divide by 16 pi? Oh, there it is. Okay. Now my last step, I see that h is being multiplied by 1/3. That's the same as dividing by 3. So I have h divided by 3. How do I undo that? Well, I multiply by 3. So I multiply both sides by 3. On this right side, I end up with just h. And on the left side, if you're multiplying by a number, it just goes up in the numerator. If I were dividing by a number, it would go in the denominator, just like in the first two steps when I divided by 16 and I divided by pi. This time I'm multiplying by 3, so I'm going to end up with 3 times 210 over 16 pi. Now, just so that we are wowed and amazed by the order and coolness of math, you could have also just taken this 210 over 16 pi and multiplied that whole thing by 3. This is the exact same statement as this one, okay? Now, this is pretty straightforward. I just very carefully do this in my calculator using brackets. 3 times 210 divided by, and then because this is naturally a group in the denominator in my calculator, I will have to put that in brackets, okay? Otherwise, what it will do is it will give you 3 times 210, which is 630. It will divide by 16, and then it will take that number and multiply it by pi. That's not what we want. We want to divide by whatever 16 times pi is, okay? It's right around 50. Anyway, in your calculator carefully, you end up with a height of approximately 12.5. Double check the question to see what my units are. We're measuring in centimeters. There we go. The height of the conical firework is approximately 12.5 centimeters. Your practice problems for lesson 8.5, volume of a cone, are on the following page in your notebook. Okay, go ahead and complete each of those carefully. Again, it's just a formula. It's given, has a bunch of parts. You can use it to find any part. You could even use it to find radius. We didn't have to do that in any of our examples, but you could do it. You're just going to have to take a square root as your last step because it's r squared, right? Enjoy.